Here we have three examples of composite functions that are trig functions. In the first example, working inside parentheses first, we're looking for the ratio sine of pi over 2. It's one of our special angles. So sine of pi over 2 happens to be positive 1. In the next step, you need to compute where does the tangent function equal 1. Well, again, we've got to consider where is tangent inverse valid, and that would be in quadrant 1 and quadrant 4. But down in quadrant 4, tangent's negative. So in tangent 1, or I'm sorry, in quadrant 1, tangent's positive. So in this case, the tangent inverse of 1 is at pi over 4. For example number 2, this one, working on the inside, we're now looking for the angle. And this isn't one of our special ratios, so I'm going to draw up a triangle to figure out what this angle is. So tangent inverse of negative 3/4 is some angle. When I go to draw this up, I have to be aware of where I can talk about the inverse function of tangent. And again, that's quadrant 1 and quadrant 4. Since the ratio is negative, I have to draw up my triangle down in quadrant 4 here. So I draw my right triangle here, and tangent is opposite over adjacent. So if this is alpha, my opposite is going down 3 and adjacent 4. You can use Pythagorean's theorem to figure out the hypotenuse of the triangle. 3 squared, or negative 3 squared, plus 4 squared is c squared, or c is 5. So once I have this, now I can look at my triangle and figure out what is cosine alpha. Well, cosine is the adjacent side over the hypotenuse, or the ratio 4/5. I knew I was looking for a ratio on this one because if I look at my outside function, that's just cosine. It's not cosine inverse, so I'm not looking for an angle. Similarly, for example number 3, however, tangent inverse of 1, that's something I should be able to figure out because 1 is one of those special values for tangent inverse. And in fact, we saw in our first example the tangent inverse of 1 is pi over 4. If I can state what the angle is, there is no need to do this triangle thing. Now you can if you want, but you don't have to. This is cosine of pi over 4, and now cosine of pi over 4 is square root 2 over 2.